Hello, doctor. I'll explain my assignment. This is the article I used. This paper studies how to produce lactobumine nanoparticles, which are protein-based particles used in food and drug delivery systems. The key quality indicators are particle size. Smaller particles are better because they are more stable and easy for biological absorption. The authors wanted to find the optimal processing conditions to minimize particle size using the Taguchi orthogonal array methods. So the first step is to select three controllable factors. So we use the a statistical graded Taguchi design. Because three factors were studied at three levels, the authors used the Taguchi L9 orthogonal array, which requires only 9 experiments instead of 27 in a 4-factor design. Choose this one. Play. Okay. L9 3 level. Okay. Factors. The factor is temperature and the pH. Rotation speed. And the survival value is rotation is this is the labels. Okay. Then it generated the same neuron experimental design as in the paper. And the particle size values from the paper was then entered into MinTabs as a response variable is particle size. Also, particle size. This one particle size. We use particle size. This is particle size. This is the original measurement reported in the paper. And then we do the Taguchi analysis. Taguchi analysis. Because our goal was to minimizing particle size, so the smaller is better. The response data A is particle size. So smaller, yes. Okay, so the results showed that aggregation speed has the strongest effect. Temperature is the second most important. pH has the weakest effect. The optimal combination was temperature is 50 Celsius, pH is 2.5, aggregation is uh, 750. This matches the conclusion of the paper. And now I'm doing the ANOVA to evaluate factor significance. I use a general linear model with general linear model. For response, I choose particle size. Factors is temperature, pH, and aggregations. Model is this one. It's right. The resulting ANOVA table showed aggregation F value is 11, pH is 58, temperature is 7.64, and this is numerically identical to the paper's ANOVA table, confirming that aggregation speed is the most significant factor, followed by temperature, where pH has little effect. And the graph is matched. This is a graph of the temperature, pH, aggregation speed, and temperature, pH, aggregation speed, and this is a ANOVA table. And so by reproducing the Taguchi ionide design and the ANOVA in Minitab, the statistical analysis reported in the paper was validated. The Taguchi method allowed the authors to reducing the number of experiments, identify the most important processing factors, and determine optimal conditions for producing small uniform protein nanoparticles. The above is the entire content. Thank you, Doctor.